total derivative. Now let's say we have a multivariable function u equals to f of x comma y, where x depends on t, so x equals to phi of t, and y also depends on t, so y equals to psi of t. Now we can substitute x and y values in u, and we can find out the ordinary derivative of u with respect to t, which is equals to dou u by dou x into dx by dt plus dou u by dou y into dy by dt. Now mind you, this is ordinary derivative. Why? Because once you substitute these values in u becomes solely a function of t. So that's why it's ordinary derivative, not partial derivative. This is also called as the chain rule. Now how do we write these chains? So in this given function, u depends on x and y, and x solely depends on t and y also solely depends on t. This is called as a dependency graph. So using this graph, now we are finding out du by dt, right? So we're gonna check how we reach from u to t in every possible way, and each way gives us a term in this summation. So from u to t we have the u to x and x to t. We also have u to y to t. So this is our first way. So du by dt equals to numerator we get du by dx. We're considering this. So du by dx into, now we're considering this, so dx by dt. Similarly dou u by dou y, and now y to t, so that is dy by dt. So if you look at these terms, basically, so in the denominator we have x, and then in the numerator we have x. So if you cancel these, we get du by dt. So it's like we get u by t term here, and here also if we cancel y, we get u by t term here, and we're trying to get u by t too. Mind you, this isn't the exact reason why, but I'm telling you so that it's easier for you to like remember, cross-check, you know. So yeah, this is our chain rule, our formula. Now let's take another case where u is a function of x and y is a function of x, and x is also a function of x. It doesn't depend on some other variable. So what will our dependency graph be? U depends on x and y depends on x. And now they ask us du by dx. How do we find that out? So our first way is u to x, right? So that is dou u by dou x. So basically u depends on x. So again, x also depends on x. There's no other variable. So we're taking this term first. So that is dou u by dou x into this. So that is dx by dx plus, and the other way is u to y to x. So that is dou u by dou y into dy by dx. So x and x get cancelled. That's what I mean, dx and dx. So we get dou u by dou x plus dou u by dou y into dy by dx. That's our other case. Now let's do a problem. This is our given problem. Z is a function of u and v here, where u equals to 80 square and v equals to 280, and we are required to find out dz by dt. So what's our dependency chart here? That would be z depends on u and v, and u depends on t, and v also depends on t. So dz by dt would be dou z by dou u into du by dt, right? Dou z by dou u into du by dt plus dou z by dou v into dv by dt. So dou z by dou v into dv by dt. So we got z equals to u plus v square. Partially differentiating z with respect to u, so v would be constant, then we'd get 2u plus 0. So we're going to substitute that 2u, and du by dt is nothing but 280, right? So it's 280 plus, now partially differentiate z with respect to v, so u would be constant. So then we'd get dou z by dou v equals to 2v. We're going to substitute that again, and dv by dt equals to 2a, and t becomes 1, so that's 2a, and we're going to write that. So we're going to substitute u and v again. So 2u is 80 square, so 80 square into 280 plus 2v is 280 into 2a. So that's 4a square t cube plus 8a square t. We can take out 4a square t common, t square plus 2, which is our answer. So this is the basics of how total derivative works. In the next video, I'll talk about total derivatives in the case of implicit functions. So see you there.